Subscribe our Nehra Classes YouTube channel to watch free live training sessions and to avail the membership facilities and additional perks, click the join button. Hello everyone, I Vikas Nehra welcome you all to session number 55 of our ongoing RHCSA version 10 training. And in this session, we will talk about system logging and logs management in RHEL 10. System logging is crucial for monitoring, auditing, debugging, and analyzing the behavior of Linux system. In RHEL 10, logging is primarily managed using rsyslog, journald, and log rotate. So what are the components that we use for logging and logs management in RHEL 10? These are rsyslog, journald, and log rotate. So in this session, we are going to cover all these components in detail. So let's start the session with first one, systemd, journald. Why do we use it? It captures the logs from the kernel in its services. The second component is rsyslog. Rsyslog, it is a traditional syslogin daemon. It can log files, databases, or remote hosts. And the third is log rotate. Log rotate we use to manage the log files, compression, and cleaning up. So these three components we are going to study in detail in this session. As I mentioned in the very first session that /var is the directory which is responsible for the logs. There we have a directory with the name as log. It is the main directory where logs are stored in RHEL machines or in any Linux machine. So let's quickly start the session with the first component, systemd, journald. What is journalctl? Journalctl is the command line utility for interacting with the systemd journal web service, which captures and stores the logs in a structured, indexed binary format covering everything from the kernel and system services to user applications. So what is journalctl? It is a command line interface tool that is used for interacting with systemd journal. So if you want to use the journalctl command, you have to make sure that its package is installed in your machine. How can you check it? You can execute rpm-qf command. rpm-qf, and you can write in brackets which journalctl, and you can put a $sign there. So this will give you the package name. Actually, systemd is the package which must be installed in your machine if you want to use the journalctl command or if you want to manage the logs using the journald. Okay, if you want, you can obviously go through the manual of this command. Journalctl, print log entries from systemd journal. Journalctl is used to print the log entries stored in journal by systemd journald.service and systemd journal-remote.service. You can go through the description. You can check the options available with this command and utility. You can check the examples as well, but you don't need to worry. I'll cover everything in detail. Okay. Unlike /var/log syslog, this one, journalctl doesn't just read a simple text log. The systemd journal stores the logs in the binary format. Okay. In previous version of machines, we use this concept where log are syslog or syslog. Journal CTL is actually different. While in case of R syslog or syslog, we keep the logs in simple text format. But in case of journal CTL or systemd journal, logs are stored in binary format. The actual log files are stored in this location where log journal, then machine ID, and after that we have different files having the extension as journal. If persistent logging is not enabled, temporary journal files may be found under this location /run/log/journal, then machine ID, and then the file name. Okay. Let me show you the actual location. So let's go to the /run directory. Then we will go to the log directory there. Then we will go to the journal directory there. There we have a directory with the name as machine ID name. So this is the machine ID. So just we will move to this location, and then if we list the contents of this location, of this directory, there we have system.journal. If we want to open this file, we cannot use the cat command because, as I mentioned earlier, it is a binary file. This file is having the data in the binary format. It is not in form of the simple text. So we cannot directly use the cat command to read the contents. If you are curious, if you want to check what are the entries there which are in the binary format, you can check the strings command. You can try this command. But even after using this command, you won't be able to get the detailed information or the proper information from this file. So how can we check the logs? How can we actually find the events from the logs? That I'll tell you. We will use the journal CTL command for that. But before that, I would like to cover the features offered by the journal CTL. It collects the logs from various sources like kernel, services, standard output, standard error. It stores the logs in binary format. The location may be changed. In case of persistent logging, you will find the logs in this location. In case if the persistent logging is not enabled, you will find the logs in the /run/log directory. Okay. If you want to use the journal CTL or if you want to use systemd journaling, you can check the service status by running the systemctl status command. So the service which is responsible for this logging is systemd_journald.service. Now, if you want to see all the logs, you can simply execute the journalctl command. On most RHEL systems, it will show newest first within a pager. That means you can use the arrow keys to navigate up and down. And you can press Q to quit. So journalctl command without any option shows all the logs. If you want to see the last 10 entries, you can simply write there -n after journalctl. It will tell most recent entries. It will only show you the last 10 entries. In case if you want to follow live logs means you want to check the events at the same time and something is happening. So you can execute journalctl -f. So this will keep checking for the live entries there, and it will show you the live entries on the screen. If you want to reverse the order, that means you want to see the newest first. So after journal CTL, you can write hyphen hyphen reverse. It will show you newest entries first in the logs. If you want to perform time-based filtering, suppose you want to check the logs since or until a specific time. How can you do that? You can mention the relative time frames like this. I want to see all the logs since today. So I can write journal CTL hyphen hyphen since today. If you want to see the current boot logs, you can execute journal CTL hyphen B command. These are the current boot logs. If you want to see the previous boot logs, you can write journal CTL hyphen B -1 for the previous boot. So since I did not reboot the machine, there are no logs showing up. List all boot with timestamps. So you can execute journal CTL hyphen hyphen list hyphen boots. So it will show you the timestamps as well. You can filter the logs by services, users, and processes. How? Suppose I want to check the SSH related logs. I can execute journal CTL hyphen U SSHD dot service. So it will show only the SSH service related logs. In case if you want to see the multiple service logs at the same time, you can mention their names like this, like SSHD, rsyslog, and you can also filter the logs at the same time. Suppose I want to see the logs since today, I can write hyphen hyphen since today. You can also filter the logs using user ID or group ID like this. Suppose I want to check the logs for group ID 1000. So there are no such logs present in the machine. Suppose I want to check for the group ID 0. 0 is for the root user. So we have the entries there. We can filter the logs using process IDs. We can mention PID after journal CTL. Let me show you with an example. Suppose we have a service, this one. This one. So let's check the logs for this service 2635. So there are no entries. Let me take the example of some other service like SSH service. This one. So logs are showing up there. We can filter executables or file paths. So we can simply mention the path of the binary file after journal CTL command. We can perform the severity based filtering as well. By priority level, suppose if warning is there, information is there, error is there, so we can filter that. Suppose I want to see the warning logs only. So I can write there journal CTL hyphen P and the priority level. Suppose I want to see the error logs. I can write there journal CTL hyphen B ERR. ERR means error priority level hyphen B for the boot logs. So these are the logs. We can define the range of the priorities as well, like this, 5 to 7. Okay. Output formatting and performance. Suppose we want to disable pager. Pager means the output directly without interactive navigation. So we can write there journal CTL hyphen hyphen no pager. This will show all the logs. It will not allow you to use the arrow keys to move up and down. You can verbose or see the logs in the JSON format. This is generally used for scripting or analysis. So after journal CTL, you can mention the service name, and after that you can write -o and the format. Suppose I want to see them in JSON, I can write there JSON. Okay. Now I will tell you how can you manage journal storage. Check how much space logs consuming. So you can write there journal CTL -- disk uses. So it is currently consuming about 8 MB of the file system space. If you want to remove old logs by size, time or count, you can easily do that. I want to remove the old logs by 1 GB. I can write there 1 G. I want to remove the logs which are older than 2 weeks. I can write there vacuum time 2 weeks. Like this. Okay. Now if you want to enable the persistent logging across reboots, actually by default, journal logs may be volatile. To make them persistent, you can use the directory. Suppose I want to use this directory. So I'll create the directory first. After that, I will execute systemd -tmp files command, and then I'll define the path for the persistent logging, and then I can simply restart the systemd journal d service. After that, this location will be used for the persistent logging. Okay. Now we will talk about the access limitations. Access limitations are there. Actually, non-privileged users see only their own logs in the machine. If you want to allow them to see the all type of logs, you can either add them in the admin group or you can provide them sudo access. How will you do that? You can simply use the user remote command and you can add them there in the systemd journal group with which they can access the logs. They can access all the logs. If you want to see the recent errors, you can execute journal CTL -xe command. This will show you the recent errors. Okay, so this was all about journal D system logging. Now we will talk about the RSys log. RSys log stands for Reliable and Extended syslog. In previous versions of RHEL Linux, like RHEL 5 and 6, we were using syslog. Syslog was responsible for logging and logs management. After RHEL 7 onwards, this has been replaced by rsyslog. So rsyslog replaces older syslog D daemon, and it offers several features like now it supports TCP. It supports module-based extensions for database logging. Backward compatibility is there, means you can check the logs of the machines, you can manage the logs which is using the previous syslog facility. In order to use rsyslog, you should have rsyslog package installed in your machine, and the service responsible for rsyslog is rsyslog D. This is the service which is responsible for rsyslog. Service is already up and running and it is already enabled in this machine because we are already using it. There is a file in etc directory having the name as rsyslog.conf. This file is actually responsible for the configuration of rsyslog utility. With the help of this file, we can manage the logs in our machine. So let me quickly explain the structure of /etc/rsyslog.conf file. So you will see in this file there are two things. At the left hand, we have the selector and the right hand we have the action. Each configuration line in this file has a facility, a priority, and action. So this is the name of the facility, which is mentioned before the dot. In each line, we have a facility there. And after the dot, we have the priority, where this asterisk is showing up. So this is the priority, like EMERGY. So this is the priority. And the third column is the action. So this is the action. So what is the meaning of facility, priority, and action? Actually, facility represents where the message originates, where this message is coming from. Mail, cron, kernel, local, whatever it is. What is the meaning of priority? Priority meaning the severity of message, whether it is debug or it is just information, whether it is critical, it is only alert, it is emergency, whatever it is. And what is the meaning of action? What to do with that message. So there are 3 entries in each line of this file which play a crucial role in logs management. Facility, priority, and action. Facility means from where the message is actually coming. Priority means what is the severity of this message. And action means where to send this message. Okay. So what are the facilities that are available in rsyslog? Let me show you. Facilities identify the log source. If auth or auth priv is mentioned there, that means it is security or authentication related information. If cron is mentioned there, that means it is a scheduled job. Log is coming from the scheduled jobs. If it is daemon, that means it is a background service. If we have kern written over there, that means it is a kernel message. If mail is written over there, that means it represents the mail servers. syslog is mentioned over there, that means it is internal rsyslog message. If user is mentioned over there, that means it is a generic user level message. And if local 0 to local 7 is written over there, that means it is for the custom use. For example, appliances. Now we will talk about the priorities. Priorities rank messages by severity. So if you check the level, debug messages have lowest priority. Info messages have slightly higher priority than debug. Notice messages have higher priority than info messages. Warning messages have slightly higher priority than notice messages. Error messages have higher priority than warning messages. critical messages have higher priority than error messages. Alert messages have higher priority than crit messages, and emergency messages have highest priority, which is even higher than the alert messages. So this priority decides the severity. Using dot priority logs messages with that severity or higher. If we are using equal to sign there, not a dot sign. If we are just using the dot sign, that means it represents the priority log with that severity or higher. In case we are using equal to sign, that matches only that severity. And if nothing is mentioned over there, that means exclude. Now let me show you with an example. So what I'm going to do, I'm going to make some changes in this rsyslog file. We will open it in VI editor and we will go at the end of this file. And what we will do, we will write a few lines. So in the first line, I'm defining the facility, priority, and action. So local 4 is the facility. It will tell from where the message is coming. After that, I'm using the dot sign. Dot sign means the priority or the severity is equal to or the higher. And crit, it represents the priority. And this is the action. It tells where to send this information. So what I want that all the messages which are having the priority of critical and above should go to this file. In the similar fashion, I want that only critical messages should go to this file. So here I am matching the label. Actually, there is a difference between this dot crit and dot equal to crit. Dot equal to crit means it will send only the critical messages, not higher messages to this file. This dot crit will send critical messages and above critical messages to this file. And in the same way, let me make one more entry here. Local 4 dot asterisk. This will send all type of severity messages to this file. No matter what is the level of criticality, what is the level of priority, all should go to this file. Okay. Now let me save this file. As you know that once we make the changes in any file, we need to restart the service so that the changes can apply there. Or for your better understanding, let me mention the details as well, because it will help you to understand. Now it's good. This information will log all the messages to this file. This information will log only the critical messages to this file. And this information here will log critical and higher messages to this file. Okay. Now, as I mentioned earlier, after making the changes in the file, we need to restart the service. So let's execute systemctl restart rsyslog command. So service has been restarted successfully. Now let's check the status again, whether the service is up and running fine. So service is up and running fine. Now, we can use the logger command to manually send the logs to the RSys log. So let me use the logger command. Logger command can be used to send the messages to RSys log service. Logger -p we are using to represent the priority. Local 4, what it is? It is the facility. Dot represents the actually dot represents what it is, match the severity level. That means the debug and above level logs should go to the RSys log, and this is the text which we want to send there. This is the message which we want to send. So what this command will do, this command will send this text or send this log message to RSys log at which priority, debug and above. In the same way, let me mention one more command here, logger -p. This time we are using the facility again, local 4, and the priority is critical. In the same way, we will send the log at emergency level. Okay, emergency log will be displayed on the screen once you execute the command. Okay, so we executed the logger command, and there we send the logs on debug level, critical level and emergency level. So let's check the files one by one. Let's check the first file, all local 4 file. All local 4 file will show all the 3 messages: debug logs, critical logs and emergency logs. Why? Because it is matching the pattern. In the similar way, if we check critical and above file, it will show 2 logs. That means critical level and emergency level, because emergency level is higher than critical level. And the third one, only crit, it will only show us the critical logs. So we can filter the logs on the basis of their severity. We can send them to different locations using the RSys log. Okay, so this is how we can decide which log to send in which file at what criticality level. Now we will talk about log rotate. What is the purpose of log rotate? As you know that log files keep on growing always. So after a certain time, we need to manually make the adjustments so that we can save the storage space. We need to trim the logs, we need to compress the logs, we need to delete the older logs so that we can effectively utilize the storage space. It requires a lot of manual intervention. To reduce the manual effort, we can use log rotate facility. So what is the purpose of log rotate? With the help of log rotate facility, we can prevent logs from growing infinitely and consuming disk space. Second is, it helps us in automatically renaming, compressing and deleting the old logs based on the policies there. And third is, it runs without user intervention. You don't need to execute any command or you don't need to manage anything. Simply a cron job will do the job. The main configuration file for log rotate is slash etc slash log rotate.conf. For service specific log rotation, you can create a file there in the etc directory under log rotate.d. Look at this. For Crony, DNF, we have different files there. So these daemon specific files define log rotation policies for services like rsyslog, httpd, ftp, auditd, etc. Inside log rotate file, you can define how often you want to rotate the logs, how old versions you want to keep before deleting, how to create new empty log after rotation, how to compress the logs with gzip, rotate only if log is at least the specific size, and append date to rotated log names. So if I show you the contents of this slash etc slash log rotate.conf file, which is the global file for the configuration of log rotate, we will find the entries like this. So what is the meaning of each entry showing up here in this file? Here, this weekly represents how often we want to rotate the logs. Here we want to rotate the logs on the weekly basis. The second entry is showing here as rotate 4. So it is there. It actually tells keep n old versions before deleting. So that means here we can keep 4 old versions of the logs. The next entry, here create is mentioned. This will create new log files after rotating the old log ones. That means after rotating the old file, it will create a new file here. The next entry, date ext. This entry use date as suffix of the rotated file. Once you rotate the log, how will you check which file it is? So after doing the log rotation, it will use the date as suffix there in the file name. If you want to compress the log files, you can just uncomment this option there. It is currently disabled. It is commented. But if you want to compress the files, you can just uncomment it. Okay. This entry here, it tells packages drop log rotation information into this directory. So that means if you want a separate file for log rotation for any specific service, you can mention the path of that particular file, or you can mention the path of the directory where you can create the file for log rotation for the specific service. Okay. If you want to check the log rotate activity, you can check /var/lib/log rotate/status. It shows the last rotation date for each log file, but our machine is new, so that's why we are not able to see anything here. What happens after log rotation? If you are using the create option here, it will create a new file for the logs, and it will add the suffix in the date so that you can check which file it was. Okay. On RHEL, log rotate is triggered daily via cron. How? So we have a file there in /etc/cron.daily with the name as log rotate. Currently we don't have this file there. So if you are using log rotate, you will find the log rotate file there. So log rotate can be triggered daily by using this file. You don't need to schedule it manually unless if you want custom intervals. So you don't need to run the cron job exclusively unless you want some custom intervals for the log rotate. Okay. If I show you the contents of /var/log, we have a lot of files there. You will find that in old machines, just have a look at the files having the name as messages. You will see messages 1, 2, and something like that. So that is because of log rotate. Okay. Now we will understand /var/log in RHEL 10. /var/log is the main log storage area for RHEL systems. It contains logs from kernel, system services, applications, and security and audit systems. So if I go to /var and show you the contents there, var directory is responsible for the logs, and there we have different type of directories. Here, log directory is very important because it contains the logs about the kernel, system services, applications, and security systems. The other directories are for other purposes like game related information, library related information and logs, FTP, DB. So where do we generally see the logs related to kernel, system services, applications, and security systems? We see them there in the /var/log directory. So inside this /var/log, we have different type of files and directories. Why do we see the directories there? Directories are just to keep similar type of logs. Suppose I want to check for the crony. So crony contains crony related logs. Cups directory, it contains the printer related logs. Journal, this directory was created by us in the previous step where we are using it for persistent systemd journaling. Okay, now we will check each and every file and directory here. So the most important file here in this location is the messages file. Journal system activities, logs, kernel events, boot messages, network changes, non-critical system errors are there in this file. This is used for troubleshooting network issues, to check boot logs after restart, and in other activities. So what type of file it is? It is a log file which contains the system activity logs, kernel events, boot messages, network changes, non-critical system errors. After that, we have a file here with the name as boot.log, this one. It contains the logs from boot process, mainly from systemd services, starting at boot. Let me show you. cd/var/log. Look, these are the boot process logs. This all local 4 file was created by us in the previous example. So it shows all those logs which were sent by using the logger command. Here we have the directory with the name as Anaconda. Anaconda is used for the kickstart installation. In case if you see the errors there, you can see those logs in this directory. Then we have this audit directory there. So if you go to this audit directory, we can see audit.log file in this location. Audit.log file is used by SE Linux. So SE Linux related logs can be seen in this file, which is there in the audit directory having the name as audit.log. So this is related to SE Linux. We will talk about it in the upcoming sessions when I'll teach you SE Linux. Boot.log, it contains the booting time logs. Then we have a file here with the name as btmp. It is a binary file. btmp, it contains failed login attempt logs. Currently this file is showing here as empty in this machine, 0 size, because there are no failed login attempts in our machine. Let me show you. I will create a failed login attempt, and after that we will have some data in this file. Let me mention the username as Vikas Nehra, and this time actually my password is already saved there. Let me change the password for Vikas Nehra. passwd. Let me mention the password as Nehra classes. Password has been changed. Now I will log out and re-log in back from Vikas Nehra user account. And let me mention the incorrect password. So I'm trying to create a scenario like failed login. Now we will check the size of this file. Now we have some data in this file. 2.3 KB. But if I check the contents, I cannot see the data properly. Why? Because this file is in binary format. So either we can use the strings command, we can see the details of this file, or we can use the last B command. Last B command can be used to check the failed login attempts, and this will extract the data from this file. Okay. So that's why we have this btmp file there. This crony directory, it contains the crony related logs. Create and above, this file was created by us in the previous example. We have a file here with the name as cron. We have already discussed about this file in the previous session of cron jobs. It contains the future job related logs here. Then we have cups directory. It is used for printers in Linux. So there we can have the printer related logs. Then we have DNF related logs. It is related to the package manager. Then we have firewall D related log file. It is for the firewall. So we have different type of files here. Like we have a file here with the name as last log. So again, it contains the information about the last login, but it is again in the binary format. So you can use the strings command. Okay. Or you can execute the last log command. It will show you the detailed information. In the similar fashion, we have a file there with the name as secure. This file contains security related messages, including authentication, success, failures like SSH, sudo, login. So it is just to identify the user. It is just to check the brute force SSH attempts. We have a file there with the name as fail log. This file is currently not showing up here in our machine. It contains binary logs for failed login attempts. If you are using PAM, pluggable authentication modules, then you will find a file with the name as tally logs. But we are not using PAM, so that's why this file is not showing up here. We have a file here with the name as WTMP. This WTMP file is a binary file which contains the logs for all logins, logouts, reboots. And how can we check the logs? Either we can use the strings command to read the file contents, or we can execute the last command. Last command actually shows the proper and detailed information from this file. Similarly, we have one more file here with the name as UTMP. This file is actually available in the Debian based machines. It is for the current session logs, and you can use the W command to check who are the users which are currently logged in. Similarly, for package management related logs, you can see from the dnf.log file. This is the file which is responsible for the DNF package manager operations like installations, updates, removals. We have a file with the name as yum.log. If we are using yum, then we can have this yum.log file. Since we are using DNF, so that's why this file is not available in this machine. If you want to see the Red Hat subscription manager related logs, you can check in /var/log/rhsm directory. And there you will see the different files like rhsm certd.log, rhsm.log. This type of information will be available there. Then we have service specific logs. Suppose if we are using httpd, then we will see /var/log/httpd directory, and there we will see the log files. Since we are not using httpd, so that's why this directory is not available in this machine. If you are using Nginx, MariaDB, Samba, so you will see different directories there for such services. Okay. Sometimes we see a file with the name as kern.log. It contains kernel specific messages. In RHEL, we will not see it. It is generally available in Debian based machines. In /var/log/tuned directory, we will see tuning related logs. What is tuning? It is used to tuning profiles are used to use the machine. What can I say? By using the minimum resources, we can provide the maximum service by using tuning profile. Actually, tuning profiles are there in RHEL, which tells what is the optimum level of the hardware that you can use. Suppose we have a machine and we have a lot of resources, but we are only using the machine for a single service. That means more than 90% of the resources are getting waste. So in order to keep an optimum level, like what are the services that we must use, whether we should use the power saver or not. So for that we use tuning profiles in Linux. So for tuning related logs we can check this file. I will cover tuning profiles in the upcoming session. You don't need to worry about it. You will see /var/log/messages. It is for the current log. If you see a file having the name like this, /var/log/messages.1, so that means you are using log rotation here, and this is the last rotation, last log rotated, last file which was rotated using log rotate. If you are using log rotation and compression, then you will see the file in this format. Message 2, that means it is the second older file which was rotated by log rotate, and it is in compressed format. GZ is the compressed file. Okay. So the var log directory, it contains a lot of files which are related to log, like wtmp, utmp, btmp. Okay. If you want to go in details of each and every file, you can just check this document. I'll show you the document. Here I covered all the files. I'll share the document with you. What is the use of this file? What is the use of this file? Everything is covered. Whether this file is available in Fedora based distributions, whether it is available in the Debian based distributions, everything is mentioned there. Okay, I'll share this file with you, and I'll share this document also. Here I've covered all the important files. So sometimes you will see the virtualization related files as well there, like VMware. So these are the virtualization related files. Okay, so that's it from my side for this session. If you have any questions related to system logging and logs management, you can ask me now.